Hey there, tech enthusiasts and curious minds. Ever wondered what powers the gadgets you use every day? From your smartphone to the machines in factories, energy is the invisible force making it all happen. But how does it work, and why should you care? In this video, we're breaking down the basics of energy, power, and efficiency in a way that's easy to understand, even if you're not an engineer. By the end of this, you'll see energy in a whole new light. So stick around, and don't forget to subscribe to the channel and activate the notification bell so you never miss an upload. What is energy? Energy is the ability to do work. It comes in many forms: mechanical, chemical, electrical, solar, nuclear, and more. One key thing to remember is that energy can't be created or destroyed. It can only change from one form to another. For example, when you turn on a light, electrical energy is transformed into light and heat. We measure energy in joules. To give you a clearer picture, imagine lifting a heavy object. 1 joule is the amount of energy needed to move that object 1 meter using a force of 1 Newton. When it comes to electricity, we often talk about energy in kilowatt hours. 1 kilowatt hour equals 3,600,000 joules, or the energy used by a device consuming 1,000 watts over an hour. Your home electricity bill is based on how many kilowatt hours you use. But what exactly is a watt? What is power? Power is the rate at which work is done or energy is used. It tells us how quickly energy is being consumed or produced. The unit for power is the watt, where 1 watt equals 1 joule per second. Let's look at an example. Imagine a motor running for 1 hour and 24 minutes, consuming 2.4 kilowatt hours of energy. How do we find its power? First, we convert 2.4 kilowatt hours into joules. Since 1 kilowatt hour equals 3,600,000 joules, 2.4 kilowatt hours equals 8,640,000 joules. Next, we convert the time into seconds. 1 hour and 24 minutes equals 5,040 seconds. Dividing the total energy, 8,640,000 joules, by the time, 5,040 seconds, we get 1,714 watts, or 1.71 kilowatts. That's the power of the motor. Understanding power helps engineers design machines that are efficient and meet specific needs. For instance, a powerful motor might be needed for heavy machinery, while a low-power motor could work for smaller devices. Heat and electrical energy. When electricity flows through wires or devices, it often produces heat due to collisions between electrons and atoms. This is called the Joule effect. Sometimes this heating is useful, like in toasters, hair dryers, or light bulbs. Other times, it's an unwanted side effect that wastes energy and can even damage equipment. The amount of heat produced depends on 3 factors: resistance, current, and time. Using a formula called Joule's law, we can calculate how much energy is converted into heat. For example, if a resistor with a value of 12.5 ohms is crossed by a current of 6.2 amps for 20 minutes, the energy lost as heat would be 12.5 times 6.2 squared times 1200 seconds. That gives us 576,600 joules, or 576.6 kilojoules. To prevent overheating in devices like computers, cooling systems such as fans are often used. Similarly, power lines are carefully designed to minimize energy losses due to heat. Efficiency in energy use. Not all the energy we put into a machine or system is used effectively. Some of it is always lost, usually as heat. The efficiency of a device tells us how well it converts input energy into useful output energy. Efficiency is expressed as a percentage and is always less than 100%. For example, electric motors and generators typically have an efficiency of about 80%. Transformers, which are used to change voltage levels, are more efficient, reaching up to 96 to 99%. On the other hand, traditional incandescent light bulbs are very inefficient, with only 5% of the energy being turned into light. LED bulbs, however, are much better, with efficiencies about 20 times higher. Efficiency is crucial in the mechatronics industry because it directly affects performance, cost, and environmental impact. Engineers constantly strive to improve the efficiency of machines and systems to save energy and reduce waste. And that's it. Energy, power, and efficiency explained. Pretty cool, right? Whether it's reducing heat loss in electronics or switching to energy-efficient LED bulbs, these concepts are shaping the future of technology. So next time you flip a switch or charge your phone, think about the incredible science behind it. What did you learn from this video? Let us know what you think in the comments below. We'd love to hear from you. And don't forget to like, subscribe, and hit that notification bell for more videos like this. Thanks for watching, and we'll see you in the next one.